Hello students, welcome back. Previously in section 1, we established the theory of integration by substitution by reversing the chain rule. I hope everybody understood. Okay, I know that's rather unrealistic. Everybody attempted and understood most of it. Probably not even that. It was a difficult topic. So for the students who weren't able to understand most of those topics, I prepared the step-by-step process. And let's follow the step-by-step process to calculate some indefinite integrals. And there are many of those. Okay, let's go with the first example. And please note that we have a composite function here, something complicated inside. And then please note that we need this dx part as well. Remember those? Even if you don't remember, well, these kind of exercises will help you. Step 1, we substitute y as the inside of a composite function. Our aim is to substitute this dx as well, so we have to take the derivative. Remember, this d is derivative. So take the derivative, dy over dx is 2x. 16 is a constant, so that's gone. And then we have to solve for dx. dy is 2x dx. dx is therefore 1 over 2x dy. And we are ready. Substitution number 1 and substitution number 2. Yes, we can do both of them. Alright, here's the integral. And that's equal to this expression where this will be y. And then instead of this dx, we're multiplying that. Oops. Let's keep it blue. Now, do we have simple integral? Please note that this x and that x there cancel each other out. And what do we have? Integral of 1/2 y to the 1/5 power dy. It's fifth radical, so it's 1/5 power. And then we can calculate the antiderivative like this. Add 1 to the power, and then we have to divide. Okay, here goes the antiderivative computation. But this is not the final answer yet. This is correct antiderivative, but it's written in terms of y. So let's substitute this back into this y here. So 5 over 12, and then 16 plus x squared to the 5/6 power plus c, and that'll complete the problem. This y here is that. So let's recap this problem. Substitution number 1, that's the inside. And then the derivative, solve for dx. Okay, we got both, red and blue. Substitute both of them into the original equation. That's the second substitution. And then if you simplify, you're going to get a y integral. That should be much easier integral than the original integral, so you can easily calculate. Got the antiderivative. And then final substitution. Y is again 16 plus x squared. That'll complete the problem. And that's what the step-by-step process is all about. Step 0, recognition, that's a big deal in calculus too, because there are plenty of other techniques. And then which one is right, that recognition is going to be important. In calculus 1 is much less of a deal. I mean, this problem is coming from this section, so it's got to be integrated by substitution. So y as the inside. And another criterion here is a derivative of that candidate flying around somewhere, and that's a lot harder to see but both are necessary in calculus too. Here, not much of a deal. And then as for all the others, substitution 1, differentiation, so for dx, substitution number 2, integration, and substitution number 3. We explain all those through this example. Okay, how about the next problem here? Okay, that's the inside, and then we want to substitute this dr as well. So let's use, say, s is 1/9 r to the third power minus 1. Let's start from there. I could have selected any other character, but we have r, so I just went through the next character, s. The derivative is, let's see, 3 comes out as coefficient, so 1/3 r squared. So ds is 1/3 r cubed dr. Therefore, dr is 3 over r cubed. R squared, excuse me. It should be squared, sorry about that. Here, squared. Yeah, take the derivative, 3 comes out and subtract 1 from the power, squared. And then somehow I made a typo here. Okay, got it back. So, step 1, substitution. Step 2, differentiation. And step 3, solve for dr. Okay, we got all those. Let's go to step 4. Substitution number 2. Substitute everything back into this original integral, excuse me. And then copy and paste that. And then this is r. And then this one here is, okay, and keep it blue. Alright, how's this integral? Is it much easier than before? One more thing, this should be s, sorry about that. Now, how's that? Is everything okay now? Alright, this r square and that r square cancel each other out, and we get the integral 3s to the 12th power ds. So we get 3 over 13 s to the 13th power. Did I do this right? And consequently, this is 3 over 13, and then we want this expression back in here. See, this s is r cubed over 9 minus 1. Please check. Did I do everything right? Here's the answer key in the notebook. Yes, everything is right. Okay, how about the next problem? This time, would you like to try? Stop the playback and then try on your own. So the inside and then dz, you're going to substitute those. Okay, what character shall I select? W is negative z squared. Okay, that's the inside of that exponential function. dw is negative 2z dz. Yeah, I could have written as dw over dz and then flip over, but I ended up skipping a step. So, are you satisfied? As for the student who are uncomfortable about this skipped step, dw over dz is negative 2z. If you take the derivative, and then flipping dz to the other side, we got that. This step here, or that step here, either one of them, many students will skip. Get this, and then get to this directly, or get this, and get to this. Here I decided to skip this part. No. I mean, yeah, you can skip, but if it is already there, there's no reason to skip now. Okay, alright, we got both of them, red and blue. So this original integral is in place of this negative z squared, I'm going to put w there, and then in place of this dz, I'm going to multiply this. Excuse me, it should be w. So that's the blue part. Did I copy and paste correctly? Okay, looks like this z downstairs and z upstairs will cancel each other out. We have negative 1/2. So negative 1/2 and e to the w power dw. Okay, no problem there. Exponential function always remain the same, so we get this. And then this w can be replaced as negative z squared, as the original problem said. And that'll complete the problem, I guess. What do you think? So inside, derivative, solve for dz, and then substitution number 2, both blue and red. And simplify, you get a double integral, which is extremely simple. And then final substitution, you get the answer. Let's see. Is that what I got over there? Yes. But somehow all those alignments are screwed up. Okay. Well, we have several more, and we don't have enough time, so let's discuss these in separate videos.